So starting off, Unit 5 is going to be all about what we call logarithms. Say that word with me. Logarithms. We also call them logs, okay? So what is the purpose of a log? Well, first off, it wants us to solve these equations. We haven't really seen equations like this before. But if I had to solve that, so basically what that's asking, 3 to what power equals 9? 2, right? 3 squared is 9. So x would equal 2 on number 1. Okay? Number 2, try that one. 4 to what power is going to be 64? 3, yep, I would agree. 4 times 4 is 16 times 3 is 64. Cool. Okay. What about this one? Can you do that in your head? No. I can't do that in my head either. Okay. I would write that out. We could write out 3 times 3 times 3 and just keep going until we get that number, right? But don't you think that would take quite a bit of time?
Can you do like the square root of 3?
Nope. So it would take quite a bit of time to find that. So how would we go about solving problem number 3? We are going to use what we call logarithms. What are you saying, Blake?
I know the answer.
Okay, shh. Okay, logarithms are used to help us solve problems with exponents that have variables. Exponents that have variables, okay? Blake, I think the reason that you got to that answer so quickly was because you have what in your hand?
Calculator.
A calculator. Okay, that's one thing too that I've got to make sure you know. That quiz next class that we're going to have is a no calculator quiz.
Wait, what?
Okay? But I'm going to tell you what we're about to do is really easy. Okay? We're going to break these down, and it's not going to be bad. So, how we mathematically do this, how we solve that problem without just having to guess. Okay? We are going to use what we call logarithmic form. Big word. Okay? So, for instance, if we had this equation right here, 25 equals 5 to the x power. First, we must identify what's the base and what's the power. What would be the base on that? 5. Good. 5 is the base. What's the power?
25.
Nope. X to the x power. 5 to the x power. Okay? What's going to happen is that the base is going to come over and it's going to also be the base of the logarithm. Okay? And how we write logarithms. We shorten the word because obviously logarithm is really long, so we shorten it to log, okay? The base, we write it really small right next to that G, but kind of like below it a little bit, okay? So log base 5 of 25 equals x, okay? So you can see that I just shifted this around, right? So that 25, it went with the base. It went with the logarithm. The x was the power. It went on the other side. That's how these are going to work every single time. And how we read that is log base 5 of 25 equals x. Okay? Let's try it. So, for instance, on number 1, I'll do the first two with you. I would write this as log base 14, because 14 is my base, of 196 equals 2, because the exponent goes on the other side. The next one, the base is 3, so log base 3 of 81 equals 4. Do the rest. Read me number 3. What'd you put for that?
Log 12, or like the 12 on the bottom.
Log base 12?
Yeah, log base 12
of
12
equals
1.
Good. Somebody else read me number 4.
Log 36, 6 equals 1/2.
Log base 36 of 6 equals 1/2. Good. Next.
Log 2,
Log base 2
yeah, 1/8, and then
equals.
negative.
Good. And last but not least.
Log base 8, 16 equals 4/3.
Perfect. Easy peasy lemon squeezy, right?
Yes.
Not bad, okay? Next up, so we converted from what we call exponential form to logarithmic form. Would you agree? We took those exponents, we made them logarithms. We're about to do the same thing, but vice versa. So we're going from logarithm form to exponential form. So the base is still the base. The x is the exponent, and it equals a. You with me? So it's just going back and forth. So for the first one, my base is 3 to the second power equals 9. That makes sense. 3 squared is 9, right? Yep, do the other 3. Alrighty, ooh, next one, example 2, what'd you write?
6 to the third, 216.
Okay. Now what?
7 to the 0 equals 1.
Isn't anything to the 0 power 1? What?
Yes.
Anything to the 0 power is 1?
Yep.
Yeah, that's important. Okay. And then last but not least,
4 negative 2 to the 116.
4 to the negative 2 equals 1 over 16. Which makes sense because a negative exponent, it moves the whole base and the power to the denominator, right? So that would be 1 over 4 squared, which is 1 over 16. With me? See it? Everybody see that? Okay. Exponent rules are going to be a big thing on these, so we got to make sure we know those basic ones. Okay? Then we have what we call common base logs. Okay, this is important. A logarithm with a base 10 is called a common log, and it can be written just like this. So whatever the log is, you don't have to write the base if it's 10. Okay? So, my calculator, all the calculators that I have in this room, anytime you hit that log button and then you type a number, it's going to automatically assume that the base is 10. Okay? That's how your calculator works. It only works in base 10. Are you with me? It will not do any other bases. Okay? So, here's what we're going to do. Okay, these are all without a calculator, so don't use a calculator on these. So here's how we do this. Okay? Keep my base, which is 7 here, to the x power, because again, I don't know what that is, equals 49, right? So 7 to what power equals 49? 2. Good. Okay.
You should make everything like this easy. It's pretty easy.
Make it all easy? The ones on the quiz won't be bad. Okay. We'll do example 2 together as well. Okay. So, 3 to the x power equals 27. What is that going to be? X equals 3. Good. All right, let's keep going. So number 3, what did we say if there was no base written? What's the base? 10. So you should have wrote 10 to the x power equals 100, and what's x going to be? 10. Good. I don't think that's right. X should be 2. Why 2 and not 10? Yeah. 10 times 10 is 100, right? So we got to take it to the second power. Good. What about the next one?
12, 0.
Yep. 12 to the x power equals 1. Well, we know that anything to the 0 power equals 1. So x should be 0. Write that over here if you need to. Anything to the 0 power is 1. Okay. Next one, log base 2 of 64. What's my base?
2,
2. Exponent?
6. Oh.
Yep, it's 6. Okay, how'd you get 6 without a calculator?
I did 2 times 2 times 2 times 2 in my head.
Yeah, you just got to keep going, right? You can do it in your head, you can write it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. I wrote 1, 2, 3, 4, 5, 6s. So 6 2s. Yes.
Okay, so going back to that, anything with the 0 power is Does that also count for 1, 2, or is that,
For 1.
yeah, like if 1 was the 0 power?
1 to the 0 power would be 1. Yep.
What happens if 1 was like the second power? Would it still be 1?
1 to the second power?
Yeah.
No, it'd be, or yeah, it'd be 1. 1 to any power would be 1, right?
Yeah.
Yep. You can write that rule too, because 1 times 1 times 1, however many ones you have, it's still going to be 1. Okay? Cool. Example 6.
9 to negative 2.
Good. X is negative 2. Okay, we talked about that one. The negative power moves it down. We know 9 squared is 81, so it's got to be in negative 2. There will be one like that on the quiz. So make sure we know that. Can have negatives. Questions on that? How do we feel about that? Pretty good? Pretty simple?
How many questions is the quiz going to be?
I think like 8, but I'm not sure. I'll look.
What? That's good for
3 points a question, right?
Shh. You wish.
I do.
Okay, what happens when you can't evaluate a log? This is going to happen, okay? Sometimes it just doesn't work, okay? If this happens, we have to use what is called the change of base formula. Change of base. Okay, so for instance, looking at this one, if I wasn't using a calculator, 5 to the x power equals 30, even with a calculator. That's going to be pretty hard to think of, right? Or to solve. Because 5 times 5 is 25, right? So 5 squared doesn't work. 5 times 5 times 5 would be 125, so 5 to the third doesn't work. Okay, so that's going to be a weird number, right? Yeah, it is, okay? But here's the thing. We can use what we call the change of base theorem to make this really easy, okay? Or to simplify it. So, some logarithms, we have to use this formula, and here's what it is. Log base x of a divided by log base x of b. Now I know what you're asking. Where'd the x come from? What is the x? It could be anything you want, okay? It could be literally any base that you want, as long as they match. Okay, so whatever base you take a to, you also have to take b to, okay? And whenever we're doing these without a calculator, we're always going to want to pick one that mentally is going to work. So we kind of got to think about these, but usually they won't be too hard. But if we are using a calculator, we're always going to pick base 10, because our calculator does that, right? Okay, so let's look at the first one. Show you what I mean by this. Okay, it's always going to be A over B, okay? And remember, B always stands for base. So if I look at this, what's the base? 16, okay? So that's always going to be the B. So write that out on the first one and make sure we know that the 64 is going to be the A. So here's what I got. I got log, I'm going to leave the base blank for right now and put 64. And then put log, leave the base blank, and put 16, because that's the B. And now here's what I want to think about, okay? Since I can't use a calculator on this. I want to think about small numbers, okay? So a small base that would multiply by itself to get both 64 and 16. So I'm going to start small. I'm going to start with 2, okay? Starting with 2. So will 2 times 2 times 2, can I eventually get that to be 64? Think about it. Yeah, we can. What can I get it to be 16 as well?
Yeah.
So that's going to work. So that's what I'm going to pick. 2. Okay? How many times do I need to multiply 2 to get 64? Or for instance, if we wrote it like what we've been writing it, 2 to what power is going to be 64? We just did this one. What was it?
6.
It was 6. Yep. Okay? But if I didn't know that, I would need to just keep doing 2 times 2. Okay, that's 4 times 2, 8 times 2, 16. Keep counting until you get to 64. Do that for 16 now. How many 2's? 4. 2 times 2 is 4 times 2 is 8 times 2 is 16. So the answer to this is 6 over 4. Can I simplify that? Yeah, what could I write? 3 over 2 or 1.5, whatever. We'll take a fraction. So that's the answer to that one. Okay? Questions on that? Okay, I want you to go ahead and try number 2. So I'll give you a minute. Okay, so what'd you put? What's A gonna be? 32. So we got 32 on top, and what goes on bottom?
8.
The 8. And then what base did you pick? 2. Good. Start small, start with 2. If 2 works, that's it. Use 2. So 2 to what power is going to give me 32? 5. And 2 to what power is going to be 8? 3. Will 5 over 3 simplify? Nope. Leave it alone. That's it. That's your answer. Okay? Let's do number 3 together. So we will write log, keep a little gap, what goes on top? Over log what? 2. All right, now let's think about what base we would use. So we'll start with 2. 2 doesn't work. Why doesn't it work? It doesn't work, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16, then 32, and then 64. So we totally skipped 54, right? Okay? Okay, Claire, so what about 1? Well, 1 times 1 is 1, times 1 is 1, times 1 is 1. So is that ever going to get to 64 or 54? No. 3 is going to be too big, because that's never going to make it to 2, right? Okay, so we found one. This one is not one we can do mentally. We must take base of 10. Base of 10 on both. And we're going to use calculator. So here's how you're going to type this in. So grab your calculator. So how you're going to type this in? You're just going to type. Hit the log button, which is right underneath that second button if you're using one of my calculators. So hit log 54. Close parenthesis, divided by log 2, and hit enter. And you should get a super long decimal, 5.75, blah, blah, blah. We'll just call it 5.75. Everybody get that?
I got a question.
What's your question?
So on the test, if it's like that, how are we supposed to get that?
There will not be one on the no calculator test,
Okay.
like that. Okay, there might be one on the calculator part, but not on the no calculator part. Okay, so again, don't ever type the base in, right? If you're using a calculator, the base is automatically 10, so don't put a 10 in there. It's already there. So just type log 54 divided by log 2, and make sure you close your parentheses when needed, okay? Number 4 should be able to be done without a calculator. So go ahead and try. Okay, so log of A over log of B. Sorry about that. Okay. There we go. What base do we pick? What did you pick? Negative 2? Well, think about it. Well, 2 times 2. No. What'd you guys pick? 6. Good.
I did negative.
You did negative 6? Don't do negative 6. Always make it positive. Okay? But now we look, okay? So here's what we're doing on top. 6 to what power is going to equal 1 over 36? Negative 2. Yep. Okay? And then 6 to what power is going to equal 6? To the first power. Okay? So negative 2 over 1 is just negative 2. All right? Questions on that?
Why don't we do it the other way because it's faster?
You can. I just have to show you this.
Oh, okay.
Because sometimes you have to do it this way. That was kind of a bad example. So negative exponents bring the base and the power down. and make it positive, right? We've learned that rule before, but write it down if you need to. Okay, cool. Questions on that? All right. Next thing, introduction to natural logs. Ooh, fun. Okay, so natural logs are like regular logs, but they're healthier. Get it? Because they're natural. No one thinks I'm funny today? Do you think I'm funny? Do you think I'm funny, Nathan?
You're just too good, we
Yeah,
can't get it.
okay. I'm too good, you can't get it? Okay, it's fine. So we talked about common logs. A common log just has a base of 10, okay? We can type those in our calculator, right? The only ones we can, okay? Common logs. So basically what this is asking, common log, so log base 10 of 10, so it's basically asking 10 to what power equals 10? And what would that be?
2.
Nope.
1.
1. Okay? Then we got log base 10 of 100, so 10 to what power equals 100?
2.
2. What do you think 1,000 is going to be?
3.
What do you think 10,000 would be?
4.
Good. So it just keeps going. Do we all see that? Okay, so those are just the rule of common log. You'll see that sometimes, okay? Those, if you can remember them, great. If not, you know how they work because they have a base of 10. Okay? Then we have what we call natural log. And the thing that is similar about common log and natural log, okay? Do you know how, or do you see how with common log, we don't have to write the base out, okay? We can just literally write log of whatever we're taking the log of, if the base is 10, okay? So with natural logs, if the base is number e, which is an irrational number that you may or may not have heard of before, it's kind of like pi, okay? So pi is like a number that keeps going forever. You with me?
Yeah.
So e is very similar to that, it's just a different number, okay? So we can take a log of base e, and we call that what's called a natural log. And the abbreviation for that is ln. Why it's not nl, I don't know, okay? But it's ln. So basically, if I'm taking log of e of anything, I can rewrite log e as just ln. So log base e of 20 would just be natural log of 20. Okay, same thing with the exponent rules. So e to the x equals 40. Well, we could also write that as log base e 40 equals x, or just natural log of 40 equals x. Okay, so we're going to practice that, and then we're going to be done today. So again, what is e? E is an irrational number. Yep, with an approximate value of, I believe it's 2.718. Let me double check. Haven't dealt with this since college. I got pi memorized, but I don't have e memorized.
Like all
My old professors used to, though. All of pi? Pretty far. 3.14159265358979323. I think it's 864 after that. I don't know. I'll have to double check it. But you can go pretty far. There's a competition once in class. Okay, so E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. So a lot of times in word problems, okay, you're going to see that base E. You're probably going to see it on the EOC, I would guarantee it. Probably the ACT too, possibly. You might have seen it before on there. I don't know. I don't write the ACT, and I have not seen it since I took it in high school. But if you see base E, just know irrational number, kind of like pi. And what we call these. So anytime we see an exponential function with base e, we call that a, give me one second, natural base exponential function. Big vocab unit. Natural base exponential function, okay? So like e to the x power equals 4. Okay, that would be a natural base exponential function. Logarithmic functions with base e are called natural logarithms. Logarithms. I think I spelled that right. Example of this would be, like, for instance, natural log of 3, okay? This is, again, abbreviated as ln. ln. And all it means is log base e of whatever, but it's just abbreviated natural log. So, last but not least, we got these 6 problems, okay? I'm going to do 1 and 4 for you, and now you're going to do the rest. So just converting back and forth between these 2 forms. So on the first one, okay, how we would rewrite this. Natural log of 24 equals x. Okay, so it's very, very similar to the regular logarithms that we did, okay? Natural log of 24 equals that exponent, which is x. Same thing going the opposite way, okay? So e to the 58th power equals x. E to the 58th power equals x would be how I wrote that one. So I want you to do the rest. We'll go over them quickly, and then we'll have the rest of the time to work. What'd you write on number 2?
ln x equals 9.
Perfect. Number 3?
ln 72 equals x plus 5.
Yep, natural log of 72 equals x plus 5. Somebody else tell me what you got for number 5. E to the x equals 6, good. And last but not least, finish us off, Lucas. Perfect. E to the 32nd equals x minus 9. Questions on that? Are we good? Are we golden?
Yeah.
We feel confident. Okay. 2 problems on Delta Math. Homework sheet. That is what's due by next class. Let's not get behind this semester. This chapter, I mean. Okay? I'm talking to all of you. Let's turn in our homework the next day. I'm especially talking to you. You know? Okay, cool.